Now on to the video. Hey guys, it's Galactic Lum and welcome to another episode in the C# 2D game engine series. So today we're actually going to be doing translations, and we're going to be doing this via matrices. And I'll explain this more in depth in the companion video to this, because this is going to be a very math focused or math heavy episode, whereas before we were just kind of doing simple GL calls. Now we're actually going to be doing some matricey math and vector math. Not so much vector math, but matricey math. And it's going to be a little more complicated, but OpenTK will handle a lot of it for us. But in our companion videos, I will actually explain how it works, which for some of you guys may be very beneficial. Anyways, let's dive right into the code. So let's create a new, oh no, let's not build. Let's create a new class. And it's going to be called transform.cs. It's not actually called .cs, but I like to do that. And it's just going to be a public class, transform. And inside here, we're going to create a private vector2, and we have to use OpenTK, and I'm too lazy to actually type that, so I'll just right-click on vector2 and use OpenTK, vector2 position. And then let's create a getter and setter phrase. And set position is equal to value. So then we'll create a public transform. So this will be a constructor, and we don't actually have another constructor, but we will have it soon. So we'll just create that public transform vector2 position equal to position, right? Basically, if you don't understand, we just created a constructor, and we just called another constructor. So when we call this constructor, really, it's just calling this constructor. And I like to do that. You notice, if you guys watch my streams or just, you'll see my tutorials, I really like to do this type of stuff because I like to have convenience methods. I don't want to retype code, and it just saves a lot of space. And time. Anyways, let's create another constructor. This should be another simplified one, because we don't always want to create a new vector when we just get passed in two floats. So we'll just say position. In fact, really, instead of typing more code, we can just even do new vector2 xy. Cool, and then we'll just move this up. There you go. Then let's create a public void translate vector2 position, and then we'll say this position is plus equal to our position, and let's create another wrapper class or class method, which will do the exact same thing, but instead of retyping the code for translations, we'll just create a new vector2 and call that code, right? We could also just say directly plus equal to x, but since it's not going to put too much dent into the garbage collector, so don't worry about that. The last thing we have to do is a transformation matrix. We have to create it, and we have to create the translation. So my idea was to put the transformation class or the transformation matrix into transform class. And the reason this makes sense and the reason we're going to do it is because this way the transform will handle the matrix stuff, which makes sense in my opinion, because the transform should be doing that. So let's create a public matrix for transformation matrix. And this will just have a get, and this will return matrix for .create translation. And the next thing about OpenTK is, especially their math library, is they handle a lot of the nitty-gritty math stuff for you, which is really good, I think. Now, again, in the companion video, I'll explain how you actually do create the translation without, having someone or some library do it for you. And if you were creating a math library, you would see that there's a lot of math, especially in matrices. There's a lot of math involved. Vectors, not so much. It's mostly just you know, getting the dot product, getting the cross, square magnitude or magnitude. That stuff isn't the most difficult of math. But when you go into matrices, especially creating translations, rotations, scaling, inverting, getting the, you know, getting the transposed matrix, it starts to get, you know, somewhat complicated. So that's what I'm aiming the companion videos to be. You know, I might even create a video series on creating your own 3D math library sometime, but just me rambling. Anyways, that's the nice stuff about OpenTK, is that it does a lot of this stuff for you. So anyways, let's create a new vector 3, and then we'll say position.x, position.y, 0. So we're creating a new vector 3, and our Z component is always going to be 0. And the reason for this is because, for example, if you've ever used Unity, you see that the transform has 3 components in their position, scale, and rotation. They have a Z. We don't need to worry about that because we're only 2D, whereas Unity is 3D and 2D. Now, you can use Z to technically order your meshes, you know, order them so one mesh is, you know, behind a different one. And we will be adding that feature in later, but that's not going to be like, it's going to be doing using a different system, not just passing in a Z. Although in the end of the day, we're just rendering at a different Z. But we're technically rendering a 3D view because we can't really have a matrix that, I mean, you could do a matrix 3, but it does not have a translation, so we'd have to code that ourselves. But really, matrix 3x3 matrices cannot hold translations. Only 4x4 because of the way it's structured, right? A 4x4 matrix holds rotation, scale, and position, as well as some other useful data. But really, we are rendering in 3D. But the difference is that we're not rendering in perspective view, which is perspective is essentially, it's a camera mode, you could think of it, or view mode. And we'll talk about view matrices later, but it's a type of view matrix which actually shows depth, whereas orthographic, and that's what we're going to be rendering in, does not show depth. So although we do technically render and do math for 3D, we don't see 3D, and we really see 2D. That's how Unity 2D works, if you think about it. In the editor, you can see that they are just planes, but if you check in your camera, it's an orthographic view, and that's essentially what we're doing. And that's why we have a 0 for the Z component, because then everything is rendered at the same Z, so we don't have to worry about that. Anyways, this is our class done, really. Later on, we will have to multiply the translation matrix by the rotation scale, but don't worry about that for now, because that'll be in the later videos. Now what's left to do is just go in our shader. So we're going to go in vertex, and I'm just going to clean up uniform color. I don't really need that anymore. That was just for demonstrations, but there you go. So in here, we're actually going to take in a uniform mat 4, and that's the GLSL matrix for transformation matrix. Then what we're going to do is, in order to apply your transformation matrix to the mesh, you actually have to multiply it by its vertex position. And think about this for a minute and you'll understand why. Because we're taking our transformation matrix and we're applying it to the vertex position, which will then be offsetted, right? So if that's essentially how we get position, scale, and rotation. But there's 2 ways we can do it, and the order in which you actually multiply it does matter. If we multiply the transformation matrix on the left side, that will work. Like, I'm not saying it won't work, but there will be an issue, especially with OpenTK and the matrix order. Basically, there's 2 matrix orders. There's row and major and column major. Now, I'm pretty sure OpenTK uses column major. I'm not too sure though. OpenTK matrix order. Yeah, I'm not too sure, but I'm pretty sure it uses column major. If someone in the comments could tell me. But I do know that if you multiply it on the left side, you'll get some funky results. I'm not going to demonstrate. Actually, I'll demonstrate that for yeah. So let's just do that. So if we multiply on the left side, just let's see what happens. So let's go in test game. We're gonna have to create a new transform. We'll have to add the uniform. Then we'll also have to create a transform. Okay. And then in here, we'll just kind of, first of all, let's remove, actually, let's keep update. We'll just say transform that translate -0.01 float 0. And then we'll just say shader.load matrix. When passing transformation matrix. Transformation matrix. And then we'll build and run. Let's just give it a little second. Oh, what happened here? Okay, so we got an issue, and object reference not set to an instance of an object. That's because we just created a new transform in here. We didn't actually set it. My bad. That should all work now. You can see that it's weird, like it's rotating, it's also scaling. And the problem is because we're rotating on the left side, when our column or our matrix order doesn't allow that. The way to fix that is you can actually transpose the matrix, which is like flipping the matrix. It's rotating the matrix. So for example, if we had a 1/3 matrix, when we transposed it, it would be 3/1. And basically what that's doing is essentially just moving this to the right side. But we don't always want to transpose it, so the solution to doing that is just moving it to the right side instead of getting some sort of call to do it. Now you can see that it does work fine. And the benefits of doing this than transposing it is, first of all, performance. Transposing a matrix isn't necessarily the most, bottleneck. It won't be a bottleneck, of course, and it's not the most resource intensive. In fact, it's not. But it does decrease performance slightly because you are transposing the matrix every time. And remember, a matrix, at least the 4x4 one, has 16 numbers. So if you're doing that every frame, it might become a little tedious and you might use a little performance. So just doing this is quicker, especially because we're doing this on the GPU. So just think about that. GPU can compute math much quicker than a CPU can. So just doing this is much better than having to transpose it. So basically this is transformation done. Let's just edit our update a little bit. Let's make it so we can move the cube around, or the quad, like that. So let's say input.get key code, or key dot a. So if we press A, then we'll say transform.translate -1 0. If input.getKey dot D, transform.translate 1 foot. And then we'll add in up and down in a little bit, but you can see that we're going really quick. And that's because we're not factoring delta time. Don't worry about delta time too much yet. I will explain what it is in a little bit. I think we can do, yeah, so we can just multiply by update frequency. That should, technically speaking, fix it. One float, -1 float, and we convert that to a float. I'm pretty sure update frequency is the delta time, and I will make a separate video explaining that. So no, update frequency is definitely not delta time. At least, yeah. I'll explain delta time in a different video. It's basically the time between 2 frames, and you can use that to essentially make your game code or gameplay logic frame rate independent. We do it a lot in game development for movement, especially because if we're running at 60 frames per second, we don't want to go faster than running at 30 frames per second. So Just a little tidbit. Anyways, let's decrease to like something like 0.01. So we're gonna go pretty slow, but it'll be fine for now. Yeah, so you can see it's jittery. The movement is jittery, but it's all right for now. If we make it even slower, then yeah, you can see that it does work though. So that's essentially translations. We could also do something where it kind of goes from one side of the screen to another side of the screen. Again, we haven't covered time yet, so I will cover that probably in the next video because that's a pretty important thing, especially for movement. Then we'll do rotations and then scaling, and that should finish up our transform stuff. Anyways, guys, I hope you enjoyed this video. If you enjoy my content, you can go hit subscribe. If you can like, you can comment if you have any questions. If you know what order OpenTK uses for their matrices, I'd love to know, so tell me in the comments below. But that's basically it. And yeah, I know I haven't made videos in a while, but I'm trying. It's definitely a little tedious to create videos, especially stuff like this where I do have to do a lot of explaining, but I hope you guys really enjoy this video because I think this one of the more fun videos because we actually got to do stuff, that moves, whereas before we only got to change the color and render. But although that's great, rendering is awesome, but I think having stuff like this where you can actually see it move and you can move the cube or quad around, it does, it boosts your motivation, I think, because then you see like, oh my god, I did that. But anyways, guys, yeah, I hope you enjoyed this. This will be on the Git repository, so if you'd like to download the code or if something's not working right, before asking me or in the comments, you can just go into the Git repository and see what you did wrong. And if you still can't find the issue, then you can ask. And guys, I also am launching a website soon, and there's going to be a new video about that, but it's my portfolio site. And from there, you guys will be able to email me as well. But I'm going to make a separate video for that. And I'm not going to give the domain yet because it's not done. Anyways, guys, hope you enjoyed this. If you enjoy my content, go on Patreon, subscribe, and like, and comment if you have any questions. Bye, guys.